Hey guys, welcome to today's lesson video. I cannot believe this is going to be the last lesson video and the last lesson that you guys are going to do for your 8th grade career. After this and a quiz, you are going to be done, which is insane. I miss you guys so much, and I cannot believe we have to end the year like this. But no matter what, God is good. God is faithful and God still loves us. And so I just pray that that is your hope as you finish off your middle school career and as you move into high school. So today we're going to be talking about the last physics lesson in motion, and that's going to be on force. So if you haven't already, go ahead and get out your interactive notebook and something to write with. So today we're going to be focusing on force, and force is the last type of motion we're going to be talking about. But before we do that, let's go ahead and recap the different types of motions, different types of motions that we have learned thus far. So we first learned about speed, and we learned that speed is the distance an object travels per unit of time. So speed calculates how far an object goes in a certain amount of time, and that gives us the object speed. We also learned about velocity. We learned that velocity includes the speed of an object, but it adds on a little element of direction. So if it travels 4 meters per second north, that would be velocity. But if we said an object travels 4 meters per second, that would just be speed. So velocity is speed plus direction of the motion the object is going. And then we've also learned about acceleration. And acceleration takes the rate of change of velocity. So in order to have acceleration, we must have velocity. We must have the speed and direction of an object. And what acceleration does is it calculates when the velocity of an object changes. And if it does, then we know that that object is accelerating. So today we're going to be talking about force. Again, make sure you're taking really amazing notes. They're detailed and they're organized. And then at the end of this video, on the second half of this video, we're going to learn how to calculate force. And then you guys are going to take a picture of your notes and turn it in. So please make sure it's at least a page long. It's nice and neat, and it has every single piece of information from these slides. So the new vocabulary that we're going to be focusing on today is force. And what a force is it's simply a push or a pull involving two objects interacting. Sometimes in physics, we often overthink what we actually already have known for a very long time. And what we do is we take things that we don't really notice and we put a name to it. And for some reason that intimidates us. But I want you guys just to remember a force is a push or a pull. So some examples is passing a basketball. If I were to throw a basketball to a teammate, I'm exerting a force on the basketball. If I am playing baseball or softball, I'm hitting a baseball with a baseball bat. There is a force exerted from the baseball bat to the baseball, and that's what makes the baseball simply fly in the air. So those are some really common examples that we see a force. Force happens all around us. It happens all the time, 24/7. There's never not a force. A force is always being exerted on you, or you are always exerting a force on something else. And you're probably wondering, well, what about if I'm just sleeping in bed? There's no force exerted. I'm not pushing anything. I'm not pulling anything. Well, you might not be creating a force, but a force is being acted upon you. And that's through the atmosphere and gravity. So the atmosphere, it's called atmospheric pressure. And that is a force. The force of the atmosphere is actually pushing down. If you've ever worked out and you've had to do arm circles for a really, really long time, you've probably wondered why it hurts so much to do arm circles for a really, really long time. Or if you were to just hold your arms in a T pose and just hold them out in the air, your arms are going to get really, really tired. Why? Well, that's because the force of the atmosphere is actually pushing down on you. And then there's another force that we talk about, you've probably heard your entire life, and that's gravity. And hopefully we're going to be debunking and you're going to be learning some new things about gravity that you've never known before. But there is gravity acting on you all the time, and that's from the Earth. Because the Earth is so big and so large, it has such a high mass. And literally anything with mass has a gravitational pull on something else. That's crazy. You have gravity. Your computer has gravity. Your desk has gravity. There's always gravity no matter where, because anything with mass has gravity. And so because the Earth is so large, the Earth has a gravity on you and it pulls you down. That's why we don't float around on the Earth, because there is a force of the Earth pulling down on us, and that's what allows us to stand upright and not float. Another force is tires on a road. Now, if you've ever wondered why we use rubber tires, it's because there is so much heat that is produced when two objects rub together. That's what friction is. That's why we have rubber tires, because if we were to have metal tires, well, the metal would get really, really hot, and so would your car, and you would probably blow up. So that's why we have rubber, because rubber is an insulator and it prevents that heat from traveling anywhere else in the car. And that heat is generated by friction, and friction is a force. And then the last force is measuring your weight. That is a force, because you are basically measuring the gravitational pull on you. So when you measure the gravitational pull on an object, we call that its weight. So let's talk about the 4 types of forces. So there's 4 main types of forces, and I've already hit a little bit on them already. Number 1 is friction, 2 is gravity, 3 is weight, and 4 is net force. I want you guys to know these 4 main types of force. In the end, we're only going to learn, because our year has been cut short, we're only going to learn the equation for net force. So that's the only thing you're going to be calculating for this lesson. If we were having a longer year, you would be learning how to calculate friction and gravity and weight. But because of our short time together and ending this year, we're only going to be learning how to calculate net force. However, you will still definitely need to know friction, gravity, and weight, and what those are and examples of them. So the first one is friction. So again, we're talking about the 4 main types of forces. So the first one is friction, a force that opposes the sliding motion of 2 surfaces touching each other. So friction happens when you have 2 objects and they slide and they rub against each other. So an example is you push a skateboard with your hand and let it go. Eventually the skateboard slows down and stops. Have you ever wondered why a skateboard slows down? Well, that's because of friction. Friction is a force between the skateboard wheels and the road. And so what friction does is, because the road is stationary, meaning it doesn't move, and because the skateboard has wheels, the wheels are rubbing and sliding past the gravel in the road, and that creates energy and heat, and that actually slows down your skateboard. Now, if friction didn't exist and you were to push that same skateboard, it would never stop. Isn't that crazy? The skateboard would never stop. If it was a flat surface forever and you were to push a skateboard and friction did not exist, the skateboard would keep going and going and going and going. But because of friction, the skateboard eventually slows down and comes to a stop. Another type of force is gravity. Gravity is an attractive force between 2 objects that depends on the masses of the objects and the distance between them. So usually when we think of gravity, we think of planets, we think about the Earth, we think about the sun, we think about our solar system, because those are the greatest masses that we can actually see and kind of interact with. So an example is you are exerting an attractive force on everything around you, your desk, family members, and even Jupiter. This attractive force acts on all objects with mass. So if an object has mass, which if it is made of matter, it has mass. If it has mass, it has an attractive force. And the greater the mass, the greater the attractive force. Now, that's why your computer is not moving towards the lamp on your desk, because the masses are so little. They don't really have an impact on each other, but there is an attractive force in everything that has mass. Now, because the Earth is very large, because the moon is very large, because they have a large mass, the moon stays in orbit around our Earth. It never goes out of orbit. It doesn't just float away, but it also doesn't come crashing down into the Earth. It has a perfect distance to where it can rotate around the Earth and it stays in a loop. And that's because the moon is much smaller than Earth. Earth is much bigger. So because Earth has a bigger mass, it has a bigger gravitational pull on the moon, which keeps the moon from just floating away into space. And the second bullet point is universal gravitation explains why you feel the Earth's gravitational pull, but not the sun's gravitational pull. The reason why you don't feel the sun's gravitational pull is because you're closer to the Earth. So it's not only the amount of mass in an object, but it's also the distance between them. And that's the second point in the definition. So the reason why you don't feel the sun's gravitational pull is because the sun is much farther away from you than the Earth. The Earth is very close to you. Therefore, the Earth is going to be the only planet in our solar system or any star that has a gravitational pull on you. The bigger an object's mass, the bigger the gravitational pull. The next type of force we're going to talk about is weight. And weight and gravity go hand in hand, but weight is a specific measurement of a gravitational force exerted on an object. So that's when we measure the gravitational force on a specific object. So when you hop on the scale, you are measuring the Earth's gravitational pull on your body. So based on how much matter you have, we're going to take that matter and we are going to calculate it based on the pull of the Earth, and that gives you your weight. Remember that weight and mass are not the same thing. Weight is a force, okay? Weight is the gravitational force exerted on you, but mass measures the amount of matter in an object. Okay, so mass and matter, we learned that at the very beginning of the year. That matter measures how much mass is in an object, how many atoms are in you. But weight is measuring what is the force of gravity on you. And then the last type of force we're going to talk about is net force. So we talked about force. I'm going to go back here for a second. We talked about force is a push or pull involving two objects interacting. So that's exactly what net force is, except net force is the sum of all the forces acting on an object in a specific scenario. So it's all the forces happening at one time. And so net just means the sum or all of them together. So an example is when two or more forces act on an object at the same time, the forces combine to form the net force. So it's when you're calculating this force plus this force exerted on an object, and that gives you your total force or your sum force or your net force. So let's give a real life example. If you and a friend are pushing a box in the same direction, okay, let's say you're helping a friend move, and you're pushing a box in the same direction. The forces are combined because they are exerted on the box in the same direction. So if you and your friend are both pushing in the same direction on the same box, the net force would be calculated by both of you because you are both acting on the box. You are both pushing or pulling on the box, and that's what describes a force. So how do we calculate it? Net force is one of the most popular forces, so we're going to learn how to calculate force, not gravity, not weight. We're just going to focus on simple force. And you've probably seen this triangle already from speed. We can use this similar triangle to help us calculate force. So how we calculate force is it's F equals m times A. And force is represented by F, m is represented by mass, and A is represented by acceleration. And so force is a push or a pull. Mass is how much matter is in an object. And then we've talked about acceleration in our last lesson. Acceleration is how fast an object is going in a certain amount of time, And as you can remember, the unit is meters per second squared. And then sometimes it can be kilometers, but for this example, we're going to keep it to meters per second squared for acceleration. For force, we use the word newtons, and that's because Isaac Newton is the person who discovered force and discovered gravitational pull, and he is the one that is accredited to really discovering what force is and how it works. And so we use the word Newton to describe as a unit for any type of force, and we use a capital N. It's not a lowercase n, make sure it's a capital N. And then we have mass, and mass is represented by grams or kilograms by a little g or a little kg. So just like we have done in the past, when you're looking for something, you're going to cover it up. So if you are looking for force, you're going to cover it up and you're going to multiply the mass and acceleration given to you. If you are looking for the mass, and you're given the force and the acceleration, you're going to divide the force by the acceleration. And if you're looking for the acceleration, you are going to divide the force by the mass. So we're going to go ahead and start practicing how to calculate force. Okay, so now we are going to go ahead and start calculating force and also mass and acceleration depending on what our word problems give us. So the first practice word problem we have is, what is the net force on a dragster with a mass of 900 kilograms if its acceleration is 32 meters per second squared west? So the first thing we're going to do is we're going to break it down. We want to know, what is it asking? Like, what do we need to find? And what do we already know? And from there, we can figure out what type of formula we're going to do, calculate it, have our unit, circle our final answer, and then we're done. So let's break it down. The first part says, what is the net force? So that is what we are looking for. We are looking for the net force. We don't know it. That is what we are trying to find. Then it says, on a dragster with a mass of 900 kilograms. So now we know our mass, or our M, and that is 900 kilograms. And the last thing it says, if its acceleration is 32 meters per second squared west. So we know our A of our equation, our acceleration is 32 meters per second squared, and don't forget the west, because acceleration will always include the direction it's traveling. So we know we're looking for F, and we've got our handy dandy triangle right here. So because we're looking for the force, we're going to cover that up. And what's left is mass times acceleration. So that is going to be our formula. It's going to be F equals M times A. So now we're just going to plug in our numbers. So we don't know force, so our F is going to come down. M, or our mass, is 900 kilograms, and I'm going to go ahead and bring my units down, times our acceleration, which is 32 meters per second squared west. And I'm going to multiply those two, and when I do, I'm going to get 28,800. And because we are looking for our force, we know that our unit for force is newtons, represented by a capital N. So we know that that is our force. Plus, we're also going to bring down this direction. So our force is 28,800 newtons west. And because that's our final answer, we're going to go ahead and circle it. Okay, so let's move on to the second problem. A car pulled by a tow truck has an acceleration of 2 meters per second squared east. What is the mass of the car if the net force of the car on the car is 3,000 newtons east? So let's figure out what it's asking and what we already know. So the first thing is, it's asking, what is the mass? So we know we are looking for the mass. That is our unknown variable. It says a car pulled by a tow truck has an acceleration of 2 meters per second squared east. So we know that that is our A, our acceleration is 2 meters per second squared east. What is the mass of the car if the net force on the car is 3,000 newtons? So we know that our force, our net force, equals 3,000 newtons east. So we know we're looking for mass. So we're going to come back up to this triangle. We're going to cover up M, and we're left with force on top of acceleration. So our equation is going to be M equals F over A. And now we are going to plug in our variables. So we don't know mass, but we do know force. Our force is 3,000 newtons east. And on the denominator of our fraction is going to be 2 meters per second squared east. And when we calculate that, our mass comes out to be 1,500. And you're probably wondering, is it pounds? Is it grams? Well, it doesn't actually tell us what our unit is going to be, but you can guess by saying a car pulled by a tow truck, okay? So we're talking about some pretty heavy stuff here. So I don't think grams would be enough. So you always have to look at what object are they talking about? What makes the most sense? And in this case, it's going to be kilograms. And that is our final answer. Okay, so that's the mass of the car. All right, last one. You push a wagon that has a mass of 12 kilograms. If the net force of the wagon is 6 newtons south, what is the wagon's acceleration? So right now we know what we need to look for. Okay, so it says, what is the wagon's acceleration? So A is going to be our unknown variable. It says you push a wagon that has a mass of 12 kilograms. So our mass, or our M, is going to be 12 kilograms. If the net force of the wagon is 6 newtons south, so now we know our net force, which is 6 newtons south. What is the wagon's acceleration? So let's go back up to our triangle. We are looking for acceleration. So we're going to come up to our triangle, cover up acceleration because that's what we're looking for. And our equation is going to be A equals F over M. So we're going to bring it down here. A equals F over M. And now we plug in. So we don't know our acceleration because that's what we're looking for. So we're going to go ahead and plug in our force, which goes on top, and that is 6 newtons south. And for our denominator, it's going to be our mass, which is 12 kilograms. And when we do that math, 6 divided by 12 is going to be 1/2, or we're going to go ahead and put it in a fraction and do 0.5. And remember that our acceleration is going to include a distance, it's going to include a time, and it's actually going to include a squared because we know that seconds is actually represented twice when we calculate acceleration, and it's going to have a direction. So when in doubt, okay, it's going to be meters per second squared. And in this direction, it tells us that it's pushed 6 newtons south. So we're going to go ahead and tag that south here. So we have our distance, we have our time squared, and then we have our direction. And that is our final answer. So now you're going to go ahead and move towards the second part of today's lesson, which is the lesson practice for force. Thanks for watching.